Okay, this is section 5.1, and this is part 3. So in the first part I talked about sets and definitions and notation and things like that. And in part 2 we got into subsets, spent a lot of time on that. And now the third part has to do with operations. So here's some other concepts regarding sets. First of all, a Venn diagram. A Venn diagram is simply a picture to help show the elements in a set. You've seen them before. I'm going to show you a few examples here in a second, and it'll make sense. The universal set, basically that's the set of all possible objects that we're talking about. When we draw our Venn diagram, it'll be designated by the letter U. Then our operations, there's 3 of them: intersection, union, and complement. Be my guess you've probably seen these before. Okay, intersection of sets is the set of all elements that the sets have in common. So notation-wise, we would put A intersects B. That little symbol, the upside down U or horseshoe, that's A intersect B. Okay. There's such a thing as disjoint sets, and those are sets that don't intersect. It's supposed to be in red, and it's not. Sets that don't intersect. Those are disjoint sets. Okay, the union of 2 sets would be the set of all elements that belong to either one of the 2 sets, and it could be both. So notice the symbol here, that's a U, that's an upside down U. So they're easy to pick out. I remember this one is a U, so U for union, A union B, and that's how you say it, A union B. So you got A intersect B and A union B. And then the complement of the set represents all the elements in the universal set that are not in the set itself. Notation, some books have A and then a small c like as an exponent. I'm going to change that. This book does a little different. Sometimes they call it A prime, but that's the complement of a set. And just in case you see it, it's the same thing as this. That's a C, just in case I write it like that by mistake. You go from one book to the next and they use different things. It's one of those two, but I've also seen this. Of course, that means not, so not in A. We won't see that here. You'll see this for the most part. Okay. So let's take a look. That's not what I want. I am missing a page. There it is. There we go. So let's define some sets here. First of all, I've got to give you U. U is the set of all elements that I'm talking about, the universal set. So in this case, we're only talking about the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Within that set, there are 2 other sets, A and B. A and B would be subsets of the original set. So A is 1, 3, 5, 7, 9, so basically the odd numbers. And B, 1, 2, 3, 4, 5. So that's basically the first 5. So I've got some things over here to the side that I want to be able to, if I put these down, you should be able to tell me what they are. So I'm going to change that right now. So if I'm talking about the complement of A, complement's an easy thing. When you look at A is 1, 3, 5, 7, 9. You ask yourself what's missing. Here's the universal set. A is basically the odd numbers, so the ones that are missing are the even numbers. So the complement of A would be a set whose elements are 2, 4, 6, 8, and 10. The complement of B Since B is basically the first 5 elements, what's missing would be the last 5. So the complement of B would be 6, 7, 8, 9, and 10. Okay, the next one I have here is A intersect B. So now you're going to look up here and say, what do they have in common? Well, they both have a 1. So my intersection would have a 1 in there. What else? Well, it looks like a 3 and also a 5. So my intersection would be 1, 3, and 5. Those are the 3 elements that A and B have in common. Okay, then we're going to go to the union. The union means it could be in one, or it could be in the other, or it could be in both. So as we look up here at A and B, I see a 1. A 1 is actually in both of them, so that would be in the union. 2 is in B. It's not in A, but it is in B, so that qualifies it to be in the union. Then you got 3, and you got 4, and you got 5, and you also have 7 and 9. So 1, 2, 3, 4, 5, 7, and 9. So if it's in at least one of the 2 sets, then it comes down here to the union. What's missing? Well, if you go back up here, 6, 8, and 10. Okay, now you can actually combine operations and do 2 at once. This says take A intersect B and find the complement. Well, A intersect B was up here at 1, 3, and 5. So you ask yourself, what's missing? Well, 2's missing. And again, you're going back to the universal set. 2 is missing. 4 was missing. 6, 7, 8, 9, 10. So just like an algebra problem, you're going to do the inside first. A intersect B, that tells me I'm talking about this set, and the complement of that would be this. Okay, and then the last one on this page, this says take A union B. Here's A union B. And then it says take the complement. So the complement A union B, what's missing? I'll see, I got 1, 2, 3, 4, 5. The first one missing is 6, and then 8, and then 10. So this is kind of an algebra in itself. You have, you know, in regular algebra, you had different properties that you could do. In operations, add, subtract, multiply, divide. Okay. Well, with sets, your operations are intersection and union and complement. And we'll talk about some other things. There's actually a whole algebra of these things that I took as a course. It's called Boolean algebra, but you don't necessarily need to know that. Okay. Let's see. Again, they're not in order. Let's do this. Okay, you've seen this before. Kind of looks like the MasterCard symbol, doesn't it? Got a rectangle with 2 circles. So inside of this, what you have is 2 sets inside the universal set. Notice I got a U up here for universal, and then I got A and B. Okay, so if I wanted to put over here and I wanted to write in set notation, what elements are in U? So anything inside a rectangle. So I'm looking at numbers here. I see a 1, 2, 3, 4, 5. What's in A? Well, here's the circle for A. I got 1, 2, 3. Set B, it's everything over here, so that's 3, 4, 5. Okay, then I've got the complement of A. Complement of A, you could think of which ones are not in A. So if I simply cover those up, what's left? 4 and 5. So the nice thing about a Venn diagram, it kind of gives you a picture. Even if you just drew the picture in your mind, you could do that. Okay, the complement of B. So here's B. Which ones are outside B? I see 1 and 2. Or, of course, you could go back up here. Here's your universal set. So if B was 3, 4, 5, what's missing? 1 and 2. Okay, what about A intersect B? Well, that's the overlap area. It's got to be in A, and it's got to be in B. That number is 3. And then A union B, that means it could be in A, or it could be in B. So any of those inside work. So it's going to be 1, 2, 3, 4, and 5. Now, a second ago, I used 2 words. I used and I used the word or. Those are 2 words we take for granted, and there's some people that don't know the difference between the 2. But basically, and always means intersection, and or always means union. Sometimes that makes things easier. So if you go back to this problem here, if I wanted A intersect B, that means it's in A and it's in B. 3 is the only one that's in both of them. It's in A and it's in B. A union B means it could be in A or it could be in B, either one. So that would be all of them. So I use those words quite a bit. Okay, now this is going to look the same. As what we just did. Go ahead and change these to the complement symbol. I have the same thing over on the right, but what I'm going to do, everything's the same as the other problem, except now I'm going to put one number. Let's put the number 6 out here. So that's a number that's not in A. It's also not in B. It's not neither one of them. So how does that change things? I'm going to change my pen here. Might fit things in a little bit better. I hope you still can see everything just fine. So U would still be 1 through 5, but now it's also going to include the 6. A still is 1, 2, and 3. B is still 3, 4, and 5. And then the complement of A. The complement A is everything outside A. So now you've got the 4, you got the 5, and this time we're going to have the 6. And those not in B, so if I covered up the B's, I've got 1, 2, and 6. A intersect B is still going to be 3. And A union B is still going to be 1, 2, 3, 4, 5. Now let's throw in 2 more. Let's do this. Let's say I wanted A intersect B. But I'm going to take the complement, and then the next one I'm going to do is A union B. Take the complement of that. And we'll use our Venn diagram to get that. So if I said A intersect B, the only number there is 3. So the complement of that would be everything else. So 1, 2, 4, 5, 6. 1, 2, 4, 5, and 6. And how about A union B and the complement? A union B is everything inside of here. So what's missing? The 6. Okay, and that all should make pretty good sense to you. This is what I would call an easy problem because you've only got 2 circles. What happens when you go to a harder one and maybe you have 3 circles? Just happen to have one here. So you can see here's the universal set, and you got different numbers, 1, 2, 3, 4, all the way up to 10. Set A is this circle, B is that circle, and C is that circle. Okay, so the things over here for you, everything in sight, so that's 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A, so you look at A, look at circle A, what's in there? I see a 1, 2, and we usually put them in order. So 1, 2, 5, 6, 7. 6, 7. B's down, let's see. B's over here, this circle. So I see 3, 4, 5, 6, and 8. 3, 4, 5, 6, and 8. C, I see 5, 7, 8, 9. It's only 4 elements there. Okay, A intersect B, so we're not looking at the numbers down in here. Kind of back to what we had in that last example with 2 sets. The intersection is the overlap area, so I see 5 and 6. Sometimes I call that a football-shaped region. So A intersect B is 5, 6. How about A union B? So forget about the bottoms. So as long as it's in at least one of them, you're okay. So 1, 2, 3, 4, 5, 6, 7, 8 would be the union. Okay, now let's compare A and C. So now I'm forgetting about what B is up here, and I'm just looking here. So the intersection there, that would be this overlap area. So I see 5 and 7. The union, I see 1, 2. I'm going to try to put these in order. So 1, 2, what's next? 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Okay, now we're going to talk about B and C. So I'm going to cover up these guys here. So the intersection of B and C is 5 and 8. And the union of B and C are all of these. So see, the smallest is 3. So 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. Okay. What if we had the intersection of all 3 of them? So it's got to be in this circle, it's got to be in that circle, and it's got to be in that circle. So there's only one thing that works, and that's the 5 right in the middle. 5's in A, 5's in B, 5's in C. So the intersection is just one element. Okay, then the union of A, B, and C, that means it could be an A, or it could be in B, or it could be a C. That would be all of these numbers. They all work. So everything except a 10. Okay, I'm going to put it below. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if I have the intersection, but now I want to take the complement, so we're saying what's missing? Well, everything really except for the 5. So I'm going to put that up here. So it's going to go 1, 2, 3, 4. Now I'm going to skip. Go to 6, 7, 8, 9, 10. So that would be the complement of the intersection. Okay, what's the complement of the union? Well, here's the union down here, so what's missing? See, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 10 is the only one missing. Okay, and then this says take the complement of A, intersect the complement of B. So that means it's not in A. Remember how I said intersection means and? It's not in A, and it's not in B. Well, that eliminates all of these because they're in A, and these are eliminated because they're in B. So what's left if I take all those out? 9 and 10. Now, this one's a little tricky. This one says not in A. Okay, I'm covering up A. So not in A is 3, 4, 8, 9, 10. Or, union means or, not in B. So I'm going to cover up those guys. 1, 2, 7, 9, and 10. So I had all of these, or I had all of these. So it's going to be 1, 2, 3, 4, 7, 8, 9, 10. So the union of A, the complement of A, and the complement of B, basically it's everything except the intersection of A and B. So you'll notice that sometimes with these operate, you might get the same answers. And there was this guy in France, and his name was de Moyer. And he came up with the de Moyer laws. And they are in the book, but what I'm going to tell you is don't worry about those. You'll figure them out anyway. He just came to the conclusion that the complement of A intersect the complement B, we just did that, is the same thing as A union B taking the complement. And vice versa, this and this one over here the same. I'm not going to hold you to that. I think it's something that if you start reading it and you're going to say, oh, I got to know that, and it might confuse you more than anything else. Okay, that takes care of section 5.1. And not too difficult, but you got to work at it. And my best advice I could give you is write things out like that. If sometimes if you had a problem like this one where you start out like this, you may draw a Venn diagram to help figure all that out. Or vice versa. If you got something like this, sometimes the best thing to do is write out your universal and A, B, and C, and then go from there. It's whatever works for you. Okay, that's it. See you next time.